Assalamu alaikum warahmatullahi wabarakatuh. Welcome to Wisdom International School's digital classroom for mathematics. So children will continue with the rational number properties of rational numbers. Okay. So we had already learnt the closure property in case of integers and whole numbers. Now we'll look at the rational numbers. Okay. So in case of rational numbers, so let's take any two numbers. Okay. I'll take 2 by 5 and let's take 4 by 5. Okay, so if I add these two, what do I get? I get 2 by 5 plus 4 by 5 gives you 6 by 5. So that's also a rational number. So if you take two rational numbers and you add it, you're getting a rational number again. So then it's a case of the rational numbers are closed under addition. Okay, now let's look at the next one. Okay, let's take the two numbers again. So 2 by 5 minus 4 by 5 is going to give you minus 2 by 5. So minus 2 by 5 is also a rational number. So it's closed under subtraction also. Okay. So if I take, let's say, instead of 2 by 5 and 4 by 5, if I take 2 by 5 and 3 by 5, okay, and if I add both of them, let us say, plus 3 by 5. So what do I get? I actually end up getting 5 by 5, which is equals to 1. So 1 is also a rational number. Okay, so if you don't get anything in the denominator, it's understood that there is 1 in the denominator. So that also is a rational number. Okay, so here also if I do minus, you get minus 1 by 5. So this doesn't work out. Anyways, it's a rational number again. Okay, now come to multiplication. So if I have 2 by 5 and you're multiplying 3 by 5, you are going to get 6 by 5, which is again a rational number. So it's closed under multiplication also. So if I take two numbers for division, let me take two numbers. See, if I take any number, it's going to work out actually. If I do 2 by 5 divided by 3 by 5, I will be dividing it like this, 2 by 5. The division will become multiplication and this will be reciprocated, 5 by 3. So I get 10 by 2 by 5. This is okay. So the 5 gets cancelled and you get 2 by 3 as the answer. So 2 by 3 is a rational number. So it actually does work out. But what if I take 2 by 3 and I divide it by 0? Then I told you that 0, it can't be, nothing can be divided by 0, right? If I have a 0 in the denominator, let's say I take just simply 2, okay, 2 divided by 0 in the denominator, so that's going to turn out to be an undefined function, okay, undefined number. So this doesn't exist. Okay, so except the 0, everything else, anything, all the numbers satisfy the division closure property under division. Okay, so that's why they say that we find that for any rational number a divided by 0 is not defined. So rational numbers are not closed under division, because we can't just leave 0 also, right? Because 0 is also a rational number, we'll have to consider it. So it doesn't work out with 0, so we say that it doesn't, it's not closed under division. But if you exclude the 0, then the collection of all the other rational numbers is closed under division. Okay, now come to the next property, which is commutative. Okay, so first we learnt closure, now we will learn commutative. Okay, so commutative says that, see, for whole numbers, let us check if addition is commutative or not. This is what is your commutative property. We just flip the positions of a and b and check if it works, if it gives the same answer. So if I take any whole number, let's say 2 and 3, okay, so 2 plus 3 and 3 plus 2 are going to be the same. If they are going to be the same, then its addition is commutative. Okay, now let's take for the subtraction, 2 minus 3 and 3 minus 2. If I do 2 minus 3, I'm going to get minus 1. If I calculate for 3 minus 2, I get positive 1. They are not equal, so I will say that subtraction is not commutative. Okay, now multiplication, so 2 into 3 and 3 into 2, both are going to give you 6 as the answer. So this is also commutative. And if I talk about division, 2 by 3 and 3 by 2 are definitely not equal, so this is not commutative. Okay, now let's come to the integers. So you take any integer, let's take one of the number as negative 5 and the other one as, let's say, 2. Okay, so minus 5 plus 2 and 2 minus 2 2 minus 5, 2 plus minus 5, is it going to give you the same answer? Yes, see, because see, this, you have taken a as minus 5 now and b as 2. So you are checking if a plus b and b plus a are equal or not. Okay, b plus a. So a plus b is minus 5 plus 2, and b plus a is going to be 2 plus minus 5, because a is minus 5. So you get minus 3 here. Here also you get minus 3. Both are equal. So it's commutative. Now if I come to subtraction, what do? Minus 5 minus 2 and 2 minus of minus 5. Okay, because a minus b and b minus a, both are definitely not equal. See, here you're getting minus 7. Here you're getting 2 plus 5, which is plus 7. So minus 7 is not equal to plus 7. So this is not commutative. Now let's look at the multiplication. Okay, so if I take minus 5 into 2 or 2 into minus 5, I'm going to get minus 10 as the answer. So it works for multiplication. What about division? Again the same problem. Minus 5 by 2 is not equals to 2 by minus 5. So it's not commutative. So now we come to rational numbers. Okay, so the same thing happens for a rational number also. When you add two rational numbers, it's going to be commutative. When you subtract two rational numbers, the same thing happens. Okay, not commutative. Multiplication is commutative and division is not commutative. Okay, now we'll come to the third property, which is called as associative. So associative is like, when you have three numbers. Let us take, you have something like 2. Let's talk about whole numbers first. So let's say one of a is 2, b is 3, and c is 4. Let me take. Okay, so if I arrange them in a different order, do they give the same answer? See, like in the first case, I will check if a plus b plus c. Look at this first condition I have written in green. A is 2, right? So wait, yeah, a is 2 plus b, so I put a bracket. Okay, b is 3 plus 4. Is it equal to 2 plus 3 inside the bracket and 4 is outside the bracket? So what does the bracket do? We'll have to solve the bracket term first. That is what you mean by the bracket. Okay, you should first look at the bracket, then only you should add. You should not add 2 plus 3 here. Okay, you should first add 3 and 4 because they both are inside the bracket. Okay, so first you should add the bracket and then you should add the number which is outside. So you get 2 plus 7. So when you have added the bracket terms, you can take out the bracket, and 2 plus 7 gives you 9. Here what happens? 2 plus 3 is 5. So first you will add first two terms, then plus 4 is 9. So both are giving you the same answer. So it's associative. Okay, whole numbers are associative. Now let us take another subtraction. For subtraction, let us check. So if I take 2 minus 3 minus 4, what do I get? I get 2 minus 1, right? First I should do 3 minus 4, which is minus 1. So then it becomes minus minus plus. 2 plus 1 is 3. Now let us check if 2 minus 3 inside the bracket and minus 4 outside works or not. I get minus 1 inside and then minus 4 outside. So I get minus 1 minus 4, which is minus 5. So here you're getting 3, here you're getting minus 5. So it's not associative. Okay, similarly you check for multiplication. So this is how you do it. Okay, it will be equal, and for division it won't be equal. Okay, so this is the property. So you can just use your own numbers and you can check. Now when it comes to integers, again the same rule follows. For addition is associative, subtraction is not associative, multiplication is associative, and division is not associative. So you know what the numbers are supposed to be taken. So you can take a rough note and check it, okay, if it works or not. Now come to the rational numbers. So same law, same property follows here also. Addition and multiplication is associative. The subtraction and division doesn't work. Okay, so now come to the next concept. Okay, so it says the role of 0. See, a 0 is a very important number. Okay, first of all, it's not a positive number or it's neither a negative number. Okay, it's neither positive nor negative. Okay, 0 has got a special value. Now if you add this 0, see, they say addition of 0 to any whole number. So any number you add 0 to any number, what do you get? Let us say you have 10 and you add 0 to it, you are going to get the same answer, right? So you take any whole number a and you add 0, you are going to get the same number. Now you take any integer, let us take minus 5, and you add 0 to it, you are still going to get the minus 5, same, right? So you get the same law. Any integer or any whole number, you add any number to that, any number to the 0, you are going to get the same number, even if it's a rational number. Let's say you have take 3 over 5 and you are adding a 0 to it. So you get still 3 by 5, correct? So 0 is called the identity for the addition of rational numbers. So see, all are rational numbers, right? So even if I take 10 or minus 5, they are also rational numbers. So you take any rational number and you add 0 to it, you're going to get the same number. So you're getting the same thing. So it's like, it's called as an identity. Understood? It's called as an identity. You get the identity, the value of the number doesn't change, right? So it's not changing the value, so that's why it's called as the identity. Okay, and it's identity for addition. So the additive identity for integers and whole numbers as well. So if I ask you what's the additive identity, you will say 0 is the additive identity. Okay, so when I ask you what's additive identity, I mean what number is should be added to any number which gives you the same number, okay, which doesn't change the answer. Okay, so 0 is the additive identity. Now come to role of 1. So 1 is also a very important thing. See, now if you add 1 to any number, it's going to change the answer, right? If I say 2 plus 1, I will definitely not get 2, I will get 3. So in addition or in subtraction, this 1 is not going to be of any use to us, okay? It's not going to give the same answer. But in terms of multiplication, if I multiply 1 to a number, 2 into 1, I get 2. 100 into 1, I get 100, right? So any number multiplied by 1, I'm getting the same number. So if I multiply a into 1, I'm going to get a, right? So this is called as 1 is the multiplicative identity. So 0 was the additive identity. So in case of addition, 0 doesn't change the answer. But in case of multiplication, 1 doesn't change the answer. So 1 is the multiplicative identity. Okay. Now come to the next concept, negative of a number. So if I ask you what is a negative of number a, you will say that, see, if a is a number, the negative of this number will be minus a. And if minus a is the number, the negative of minus a will be plus a. So it's minus of minus a, which is equals to plus a. So if I ask you, okay, 3 by 5 is there. What is the negative of this number? It's going to be simply minus 3 by 5. Okay, if I ask you, okay, what is the negative of minus 3 by 5, you have to put, it's a negative of that number, right? So minus of minus 3 by 5, which is going to give you 3 by 5. So you just have to change the, so if you look at the answer, you're just changing the sign, that's all. If you have a positive number, if they ask you what's the negative of the number, you're going to put a negative sign in front of it. If already there is a negative number, then you put a positive sign, that's all. Okay, so write all these properties also in your classwork and learn them, understand them, and then learn them. Okay, you'll be asked questions based on whatever properties been taught, multiple choice question or fill in the blanks, all those kinds. Okay, so see you with the next video. Allah Hafiz. Thank you.